Welcome back to the deep dive. Today, we're plunging into the fascinating yet often overlooked world of earthen art.
It's a really interesting area.
Definitely. Our mission today is to unpack what pottery, terracotta, and ceramics truly are. We'll also look at how these ancient materials, perhaps surprisingly, deteriorate over time.
And of course, the intricate, sometimes really challenging process of their conservation.
Exactly. So let's dig in. What should we start? Maybe with the basics.
It's a
Ceramics.
good idea. So when we talk about ceramics, we mean materials that are permanently changed when they're heated.
Yeah.
Clay is the classic example, right?
Right, clay.
Once it's fired, and that's typically somewhere between, say, 350 and 800 degrees Celsius, it undergoes this permanent chemical change.
Permanent change.
Yeah, it becomes water insoluble. That means it won't just turn back into mud if it gets wet, even after, centuries.
Okay, got it. So what's the difference then between pottery and ceramics? Are they the same thing?
Not quite. Pottery usually refers to containers made from clay, pots, bowls, that sort of thing, but it can also mean sculptures.
Okay.
Ceramics is the broader term. It covers pottery, sure,
Right.
but also things like glazes and even some industrial materials. Much wider category.
Right. And terracotta, many of us picture that classic reddish-brown color. Is that always the case?
That's a good question. So terracotta literally means baked earth. It is a specific type of ceramic pottery.
Baked earth.
Yeah, it's made from a fairly coarse, porous clay that's rich in iron oxides, usually fired a bit higher, maybe 600 to 1,000 degrees Celsius.
Uh-huh.
Now, the raw clay itself, it can actually vary in color. That characteristic red you mentioned often comes from the glaze that's applied.
Ah, okay. So it's not just what it's made of, but how it's made, the firing that really matters for its future.
Exactly. That firing temperature is absolutely key, especially for conservators. You've got different types. Well, there's unfired clay, which is still water-soluble, very unstable. Then low-fired earthenware, say 1,000, 1,200 degrees C8. It's water-insoluble, but still pretty porous.
Porous, so it absorbs moisture.
Like a sponge, yeah. Makes it very susceptible to certain kinds of damage. Then you go higher to stoneware and porcelain.
Those are fired much hotter.
Right, 1,200 to 1,400 degrees C, even higher sometimes. They become non-porous, incredibly hard, almost glass-like.
But maybe more fragile in other ways?
Exactly. They can be quite brittle. So this whole spectrum of firing really changes how each material behaves over time and how it breaks down.
It's incredible, really. Some pieces seem so durable, yet they're facing these hidden vulnerabilities. So, given all these types, what actually causes them to degrade?
Well, the main driver is interaction with the environment. It sounds simple, but it covers a lot.
Okay.
Physically, you can have problems right from the start, manufacturing defects. Maybe the design wasn't great, or the firing was careless, too rapid, uneven drying that causes cracks.
Built-in problems.
Kind of, yeah. Then there's just general use, handling, storage that leads to impacts, abrasion, nicks, cracks, blemishes, wear and tear.
Makes sense.
And environmental factors can be huge. Frost is a big one for porous ceramics. Water gets in the pores, freezes, expands.
And pushes the material apart.
Exactly, like
Yeah.
tiny wedges.
Yeah.
And mold growth, too, especially on unglazed, porous pieces if the humidity is high.
Yikes. So that's the physical side. But you mentioned interaction with the environment. Is there a chemical side, too?
Oh, absolutely.
Yeah.
And chemical deterioration can be, well, really insidious. Water itself can be a problem for low-fired ceramics. It can dissolve components or even deform the object.
Wow.
Or water can carry damaging things in, like solutes. But the really big one, the one conservators often battle, is soluble salts.
Soluble salts, where do they come from?
They can be naturally present in the clay, or they can be absorbed from the environment. Think about objects buried in the ground for centuries. They soak up salts from the soil.
Okay. And why are they so bad?
Because they react dramatically to changes in humidity. When humidity is low, the salts crystallize. And when they crystallize, they expand.
Expand inside the ceramic.
Yes. Then when humidity goes up, they dissolve back into solution and shrink. This constant cycle of expanding and shrinking exerts immense pressure on the ceramic structure, especially near the surface.
I can just picture it pushing everything apart.
It literally pushes the surface off, the glaze, everything. Leads to crumbling, spalling. It's a major cause of destruction.
So this rate of deterioration, it's not just random, it's influenced by the environment.
Definitely. It's scientifically understood. Temperature, relative humidity, even light exposure, they all influence how quickly or slowly this decay happens, if you can control those factors.
You can slow it down significantly.
Precisely. Which leads us right into conservation.
Right, the art and science of preservation. What's the conservator's role in all this?
Well, fundamentally, conservation is dedicated to preserving these objects, whether they have huge historical significance or deep personal value. It's about extending their life, their story.
And that often starts with trying not to intervene too much, right? Preventive care.
That's the ideal, yes.
Yeah.
Non-interventive care first. Environmental control is paramount, keeping the temperature stable, maybe around 68 Fahrenheit, plus or minus a few degrees, and relative humidity stable too, say 50% plus or minus 5.
Why those specific numbers?
They represent a good balance for many materials, helping to minimize both physical stresses, like from expansion and contraction, and chemical reactions, like those salt cycles we talked about.
Got it. And what else in preventive care?
Proper display and storage. Seems obvious, but it's vital. Using protective linings in shelves or drawers, padding supports, definitely avoiding stacking fragile pieces, and making sure the materials used for storage aren't harmful themselves. Some foams or felts can off-gas damaging chemicals over time.
Things you wouldn't even think about.
Exactly. And handling, of course. Treat every object as fragile, even if it looks sturdy. Hold it by the strongest part, usually the base, and always use both hands. Support the weight properly.
Okay, so that's prevention, but sometimes you have to intervene, right? Active conservation.
Yes, when damage has already occurred, or the piece is inherently unstable, that involves several steps. Cleaning is often first.
Just dusting.
Sometimes. Mechanical cleaning, like gentle dusting or carefully picking off surface dirt. But sometimes it's chemical cleaning, using carefully chosen solutions or solvents to remove grime or stains without harming the ceramic itself. Archaeological pieces coming straight from the ground need very specific care, especially if they're damp and full of salts.
Delicate work.
Very. Then there's consolidation. That's about strengthening weakened or fragile areas. If the ceramic is powdery or crumbling, you might introduce a binding material, a consolidant, that penetrates and helps hold it together. Especially crucial for excavated pieces that might have lost their original internal bonding over time.
So adding something back in to stabilize it?
In a controlled and ideally reversible way. And finally, repair and reconstruction. If pieces are broken or missing, you need to put them back together.
Like a jigsaw puzzle.
Sometimes a very complicated one.
Yeah.
We use conservation-grade adhesives, things like Paraloid B72, which is an acrylic resin, or certain epoxy resins. They're chosen because they're stable, they don't yellow badly over time, and crucially, they're reversible.
Reversible, you mean you can undo the repair?
Yes, that's a key principle in modern conservation. Future conservators might have better techniques or materials, so you want them to be able to safely undo your work if needed. For missing parts, fillers are used, sometimes traditional materials like plaster of Paris or more modern wax resins or epoxy putties, which can be shaped and toned to match the original.
Now, I've heard stories about the madness of previous restorations. Is dealing with old repairs a big challenge?
Oh, it's a huge challenge, a critical one. Conservation ethics and materials have evolved dramatically.
So past restorers maybe didn't know better or used materials that caused problems later.
Exactly. Think about it. Someone 50 or 100 years ago might have used animal glue or shellac or early plastics like cellulose nitrate to stick fragments together.
Stuff that seemed like a good idea at the time.
Maybe. But now, that animal glue might be incredibly brittle and dark. The shellac might be yellowed and cracked. The cellulose nitrate could be degrading and actually becoming acidic, damaging the ceramic itself.
Oh, wow.
And the fillers they used might have shrunk or expanded or discolored badly. So a modern conservator often has to spend a lot of time just carefully removing these old, failing, sometimes damaging restorations.
How do you even do that without damaging the original artifact more?
Very, very carefully. It often requires painstaking work under magnification. Sometimes it's mechanical removal, gently scraping or picking away the old material. Sometimes it involves using specific solvents to soften or dissolve the old adhesive or fill, applied very precisely to avoid affecting the original ceramic or glaze. It really is like delicate surgery to undo past interventions before you can even start the new treatment.
It sounds incredibly complex. So wrapping this up, understanding the basic nature of these earthen materials, how they were made, and all the different ways they can degrade, it really helps you appreciate the skill involved in keeping them around, doesn't it?
Absolutely. It's a constant dialogue between the object, its history, its material science, and the environment.
A fascinating deep dive. Thanks for unpacking all that.
My pleasure. And maybe, a final thought for everyone listening. Next time you see a piece of pottery or ceramics, maybe in a museum, maybe even in your own home, take a moment. Consider its journey through time, its hidden vulnerabilities. Think about how our choices, how we handle it, the environment we keep it in, impact its ability to keep telling its story. We all play a part, really, in their silent, ongoing legacy. What quiet journey might the objects around you have taken?